which is the same as, if you replace the K by 1 over 4 pi epsilon naught, it will become Q inside divided by epsilon naught. And this is the statement of Gauss's law, where the value of epsilon naught is 8.85 times 10 to the negative 12 coulomb squared per Newton per meter squared. Alright, let's practice a couple of simple examples with this. Surfaces S1, S2, S3 all enclose the same amount of charge. There you got, this is surface S1, this is surface S2, and this is surface S3. All of them enclose the same amount of charge. That means, according to Gauss's law, the net flux leaving any of those surfaces must be equal to 4 pi k times Q inside. You see that? There is no difference in the flux leaving any of these surfaces. Now compare the net flux leaving each surface. What is the comparison of the flux leaving each surface? The flux leaving each surface is the same. Is that right? Yes. What is the net flux crossing the surface shown here? What is the net flux crossing this surface? Well, the number of field lines entering the surface equal to the number of lines leaving that surface. Therefore, the net flux crossing the surface is 0, because whatever field lines enter the surface also leave it. Therefore, the net flux crossing that surface is 0. Let's do an example here. An electric field is E equal to 300 Newton per coulomb I for x greater than 0 and E equal to negative 300 Newton per coulomb I for x less than 0. I hope that concept you can now understand. What that means is, this is the origin. Now on the right side the electric field is positive, on the left side the electric field is negative. Obviously that field is produced by a positive charge at the origin. Is that right? That's the only way this field can exist like this. An electric field E equal to 300 Newton per coulomb I for positive x values and E equal to negative 300 Newton per coulomb for negative x values. Alright, a cylinder of length 20 centimeter and diameter 4 centimeter has its center at the origin. You got a cylinder lying along the x-axis with its center at the origin, such that one end is at x equal to 10 centimeter, the other end is at x equal to negative 10 centimeter. This is the way that cylinder is going to look like. That is the cylinder. This is x equal to 10. And this is x equal to negative 10. Alright, we will have a neat diagram drawn, but as you read the problem, try and understand what is given in the problem. Alright, what is the flux through each end? What is the amount of flux leaving the spherical surface on the left? What is the amount of flux leaving the surface on the right? Now, what is the flux leaving anywhere else on the cylinder? Alright, let's now set it up. Now, this is the picture. You have E equal to 300 Newton per coulomb for positive x, E equal to negative 300 Newton per coulomb for negative x, and here we have a cylinder with its center at the origin, one end at x equal to 10, the other end at x equal to negative 10. Now what is the area of cross section of one end of the cylinder? Well, you can see the cylinder is something like this. Is that right? Now, this is how the cylinder is. What is the area of cross-section of one end of the cylinder? It is area of cross-section is the area of this circle, pi r squared. So A is pi r squared, and what is the radius of that cylinder? The radius is 4 centimeter. That will be pi times 0.04 squared is 0.005 meters squared. All right. I hope you can now understand what is happening here. All right. Here we have a cylinder. This is the cylinder, and electric field lines are coming out of this. These electric field lines are coming out of it. So, what is the total flux leaving this surface? This is, if you know the area and multiply the area by the electric field. Remember, electric field is flux per unit area. So, if you multiply the electric field by the area, you get a measure of the total flux leaving that end. Similarly, if you multiply the electric field by this area, you get the total flux leaving that end. All right. So the flux leaving one end, phi equal to E times A. E is the electric field and A is the area of one face of the cylinder, and that will be, electric field is 300 Newton per Coulomb. Area is 0.005 meters squared, and that total flux leaving one end of the cylinder is 1.5 Newton meter squared per Coulomb. Well, that means there is flux leaving the cylinder at both ends. This is the cylinder. There is an amount of flux leaving the cylinder on the right side, which is 1.5 Newton meter squared per Coulomb. You have similarly an amount of flux leaving the surface on the left. Now remember, when I say my right, that is your left, and my left is your right. So there is a total amount of flux phi equal to 1.5 Newton meter squared per Coulomb leaving this end, and a total flux of the same quantity leaving that end. Therefore, what is the net flux leaving the cylinder from both ends? It will be the sum of those two. So phi right equal to phi left equal to 1.5 Newton meter squared per Coulomb. The net flux leaving the right side of the cylinder equal to the net flux leaving the left side of the cylinder equal to this quantity. And B, what is the net outward flux through the entire cylindrical surface? What is the net outward flux through the entire cylindrical surface? This is the cylindrical surface. What is the net flux, the net outward flux crossing the cylindrical surface? Can you tell me? The electric field is an X field. There are no field lines in the Y direction. Therefore, if this is the cylinder there, the electric field are only along the X-axis. There are no fields in the Y direction. What does that mean? It means there is no flux crossing the cylindrical surface. Does it make sense? The flux through the cylindrical surface is zero because there are no field lines crossing the cylindrical surface. Therefore, the net flux is 1.5 Newton meter squared right added to 1.5 Newton meter squared per Coulomb, that is to the left. The sum of that will be 3 Newton meters squared per coulomb. That is the total flux leaving that cylindrical surface. Now, what is the net charge inside the cylinder? What is Gauss's law? Gauss's law says the net flux leaving a surface is 4 pi k times q inside. This is the net flux leaving the cylindrical surface. That means there must be a net charge inside, given by 4 pi k times q inside, or we use the other equation. The net flux is q inside divided by epsilon naught. Any of those two equations will be fine. And now we know the net flux. Phi net is 3 Newton meters squared per coulomb. And we know the value of epsilon naught. Therefore, we can find the amount of charge inside the cylindrical surface. Q inside divided by epsilon naught equal to phi net, which is 3 Newton meters squared per coulomb. Therefore, Q inside is 3 times epsilon naught, and that will be 3 times 8.85 times 10 to the negative 12, and that will be 2.66 times 10 to the negative 11 coulombs, and that is the amount of charge inside the cylinder. And this electric field is actually produced by that charge. Alright? I hope you understand the way we use Gauss's law to solve this problem. Alright, review that one more time. Let's do another problem. A